This is Geometry, Unit 1.8b. We're going to talk about measures and angles, angle addition postulate. We've talked about the segment addition postulate before. Today we're going to talk about the angle addition postulate. What we remember about these addition postulates is there has to be a small part, and a big part. So when we do these calculations, we're looking for those three bits of information. If P is in the interior of angle, we need to be sure the angle symbol is in these, angle RST, then the measure of angle RST is equal to the sum of the two smaller parts. It's equal to the sum of the measures of angle RST and angle PST. If P is the interior of angle RST, then the measure of angle RST is going to equal the measure of the small part RSP plus the measure of angle PST. So remember that is small part plus small part equals big part. To use this formula, we need to be sure that we have three bits of information. In this case, when we look at this first problem, the given information says that the measure of angle, you need to get your angle symbol in there, is 155. So this full angle in here is going to be 155 degrees. So we know what the big angle is. We're going to try to find the small angle, GFH, which we know starts out with 4x plus 4, and the other small angle, HFJ. So if you would like, you need to at least mentally see that you have a small part plus a small part, and that's going to equal a big part. It's okay if your mind just thinks that. You don't have to write it down, but if you like to do that to stay organized, I think it could help you know if you should be using this angle addition postulate. Can you put something in for the small part? We know our small part is the measure of angle GFH. And the other small part is angle HFJ. And the big part is the measurement of angle GFJ. So we have three separate angles, and we have information for all three angles. We know that GFH is 4x plus 4. HFJ is 4x minus 1. And the largest angle, GFJ, was 155. Notice how we substituted in values in all three parts. If you can't substitute in for all three parts, then it's not appropriate to use angle addition postulate. So now we're going to collect our like terms. Notice that the 4x and the 4x are on the same side of the equal sign. So if they're on the same side, we don't have to say minus 4x. We say 4x and 4 more x's. That gives us 8x. Subtract 4. Nope, take that back. That's funny. Nope, we're on the same side of the equal sign still. So we are going to group the positive 4 and the minus 1. That's going to give us a positive 3. Now we'll be going to the opposite side of the equal sign to group our like terms together. So now we have to do the opposite. So we have 8x that equals 152. Now to get x by itself, we have to divide by 8. Well, I'm not sure how many times 8 goes into 152. But I know how many times 8 goes into 15. 8 goes into 15 one time. How many would be left over? If 8 goes in there one time, which is 8, how many do I have to get up to 15? We have 7 more to go. So I often like to write it almost like a carry the 7. So now I have 72. How many times does 8 go into 72? If you look up on your number chart, 9 times. So we know now that x is going to be 19. We didn't have to use a calculator. It's very helpful if you know your multiples up through 10. And that'll help you calculate so many of these. So x is 19. Now we're supposed to find the measurement of angle GFH. So GFH is 4x, so that's 4 times 19, plus 4 more. Well, again, I'm not sure what 19 times 4 is. But I do know that 4 times 20 is 80. But I'm going to only do 4 times 19, so that's actually 4 less. That's 19, that's 1 less, and then another 19, that's 2 less, another 19, and another 19. So that's going to be 76 plus 4, and that takes me right back up to the 80. So the measurement of angle GFH is 80 degrees. You can circle that answer. They also would like us to find the measurement of angle HFJ. So this is going to be 4 times 19 minus 1. Well, we've already learned that 4 times 19 is 76. It's 4 less than 4 times 20. Minus 1 is going to give us 75. That is 75 degrees. You should always check your answers to be sure that the 80 and the 75 are going to add together to what the largest value is supposed to equal. Check your answers, check your work. And that's equaled out to 155. All right, if you're home watching the video, pause the video. Give example number 2 a try. There's something a little bit tricky with number 2. See if you can figure that out, and then come on back and we'll talk you through it. Now we'll get ready to work through this problem. I noticed that angle VRS is a right angle. Well, we've learned that a right angle means 90 degrees. So this box implies that the larger angle is 90 degrees. Now I have a small part, and I also have a big part. I know the big part is 90 degrees. So if you like to write the word small part plus the small part, and that equals the big part. You don't have to use the words there, but if that helps keep you organized, I think it's a good thing to recognize what your mind might automatically do. The small part is the measurement of angle VRT and the measurement of angle TRS. That's going to equal the measurement of angle VRS. Small part plus small part equals big part. So the measurement of VRT is x minus 4. The measurement of angle TRS is 3x plus 2. And we've realized that the right angle is going to give us our third bit of information. Now we've written our equation. Now we go back to algebra class, And we recognize that these x's are on the same side of the equal sign. So we do exactly what it says. A positive x and a positive 3x's gives us 4x's. We have negative 2 plus 2, or you can think about it as you have a positive 2 and you take away 4. That means you have a negative 2. And now we have our equation where we have to add to get to the other side. That's 92. Now I'm not sure how many times 4 goes into 92. But I do realize that 4 goes into 9 2 times, and that would give us 1 left over. So the 4 is going to go into 12 3 times, and I'm able to do my calculation for x without a calculator. You don't have to be calculator dependent. Then it asks us to find the measurement of angle VRT. That was x, which was 23, minus 4, tells us that VRT is 19 degrees. Flip over. We have another one. So go ahead. Look over this one. Pause the video. Give it a try. See what you think. Try to figure out what's different about this. How is it the same? What are you going to do? We eventually want to know what is the measurement of angle XWZ. Right, when we look here at example 3, we notice that ray WY bisects the angle XWZ. If it bisects the angle, then that means both sides, both little angles, have to be the exact same measurement. Bisect means cut it exactly in half. Cuts it exactly in half. Notice in the picture you have a little curve and you have another little curve. Those are tick marks for angles, and that's telling us that those two angles are the same measure. So we know that the one angle is 29, XWY is 29. If the ray bisects the big angle, we know that this is 129. So if we have a bisector, then I know that angle XWY is going to be congruent to angle YWZ. When you see bisector, then you know you have two congruent parts. That's what you want to get used to writing. Notice how this is not small part plus small part equals big part. When you have bisector, you have two congruent angles. So we know that the measurement of angle XWY has to equal the measurement of angle YWZ. So now we can substitute in that XWY is 29. So mathematically, we have shown that YWZ has to be 29. So 29 plus 29, the two small parts are going to add up to the larger angle. And that's 58 is the measurement of XWZ. But that all came from this idea of the big angle being bisected, being broken into two congruent parts. Let's come on down here for the next one. Geometry problems that do not have a figure drawn are a lot more difficult. So draw your picture. You're trying to draw a picture where WY is going to bisect XWZ. So you must have an XWZ. That's a bigger angle. And angle WY, or ray WY, is going to bisect that. That means cuts it right in half where both of these sides are exactly the same. Both these angles, both small parts are the same. When you have a bisector, that's what happens. So we're going to find the measurement of XWZ, given that XWY is X plus 13, and YWZ is 3X minus 17. Now what happens here, a lot of people think small part plus small part equals big part. But you don't have a big part. You don't know what the big angle is. It's not a right angle, nothing tells us that. It's not a straight angle, nothing tells us that. So we don't have an idea. But if we go back to this idea of bisects, then we know that angle XWY has to be congruent to angle YWZ. A bisector is going to create two congruent parts. So if the angles are congruent, the measurement of angle XWY is supposed to equal the measurement of YWZ. So this is where we have X plus 13 equaling 3X minus 17. Here is your equation. We couldn't do an equation where we add them together. That wasn't going to help us get anywhere because we don't know what their total sum was supposed to equal. But if we know that they equal each other, then you can set up our equation in such a way that we can subtract x from both sides. That leaves us with 13 equals 2x minus 17. Then we add our 17 across, and that gives us 2x that equals 30, and divide by 2, and x equals 15. So it asks us to find XWZ. Well, I can find one of the angles. XWY is going to be 15 plus 13, which is 28. So the measurement of XWZ is going to be 28 plus 28, which is 56.